Lesson 2, evaluating absolute value expressions. Essential question. How can two numbers have the same absolute value? So first of all, before we get into absolute value examples, we've got to talk about what does absolute value mean. Absolute value is the distance from 0 on a number line. So think about distance is always positive. You can never travel a negative distance. You're always going to go a positive distance. So that's the first thing that we have to remember is that absolute value is always going to be positive because we're always talking about distance. So even if I think about a number line, if I ask myself, how far away is -3 from 0? Well, it's 3 spots away. How far away is +3 from 0? Also 3 spots away. So no matter what, distance or absolute value is always going to be positive. Okay, so what two numbers have an absolute value of 7? Well, we know that +7 has an absolute value of 7. That one's the easier of the two. But what other number has an absolute value of 7? What other number is 7 away from 0? So if I go count this, 1, 2, 3, 4, 5, 6, 7. What other number is 7 units away from 0? Well, -7 is. 1, 2, 3, 4, 5, 6, 7. So the absolute value of -7 is also 7. So the answer to this question is 7 and -7. What is the value of each of these? So we've got 4 absolute values on the left-hand side, and I need to write what the absolute value of all 4 of them are. So we'll start out with just the absolute value of 5. Well, the absolute value of 5, how far away is 5 from 0 on a number line? 5 spots. Okay, so we finished that one. How about the negative absolute value of -5? Now here's the trick with this. We always work with what's inside of our absolute value first. So let's take this right here. What is the absolute value of -5? It is 5. But on this one, I also have this negative out in front, so I have to put the negative right there. The negative is not inside the absolute value, so that gets put onto the 5 at the end. All right, so our third one, the absolute value of -5. Well, how far away is -5 from 0 on a number line? 5. And then we have the negative absolute value of 5. So I'll look at what's inside the absolute value lines first. And that's just a +5. And then if I put this negative that's outside out in front, I end up with -5. So you'll notice that not all of our answers ended up positive. Yes, we know that absolute value is always positive, but if you have a negative sign outside of your absolute value, your answer could end up being negative. All right, so evaluate each absolute value expression if x equals 5 and y equals 3. So here's our first one. So we have the absolute value of 17 minus, and then I'm going to replace y with 3, plus 23. Now you got to be careful on these problems that you're making sure that your absolute value bars don't look like 1s. You don't want to get those confused and think that those numbers are 1, 17, and 31. We're going to solve this problem as if it was a PEMDAS problem. I always like to work inside of my absolute value signs first. They're kind of like my parentheses in an absolute value problem. So 17 minus 3 is 14. The absolute value is 14 is 14. 14 plus 23 is 37. Absolute value of x minus 7, so 5 minus 7 plus 15. Well, 5 minus 7 is negative 2 plus 15. One important thing to remember is you don't take the absolute value of anything until you're down to just one number. So up here we were down to just the 14 in the absolute value bars, so then I wrote 14. Here we're down to just negative 2, so just one number, so now I'll take the absolute value of it. The absolute value of negative 2 is 2. 2 plus 15 is 17. Alright, same idea, but this time our x value is going to be negative 3. Our y value is going to be 2. Alright, so we have negative, and then negative 3 minus 7.
Lori McCready, please call extension 6801, Lori McCready, 6801.
Plus 9. Okay, so PEMDAS again work inside of my parentheses. The absolute value of negative 3 minus 7, negative 3 and negative 7 make negative 10. Bring down that minus sign in front. So now I want to take the absolute value of negative 10. The absolute value of negative 10 is positive 10, but then since I have this minus sign out in front, I'm going to put the negative in front of the 10. So I'm going to have negative 10 plus 9, which is negative 1. Negative 11 plus xy, which would be x times y. So we've got negative 3 times 2 minus 15. All right, so now this time inside of our absolute value, we've got addition and multiplication. So we know with PEMDAS, multiplication comes first. So I'm going to multiply negative 3 times 2, which is negative 6. Negative 11 and negative 6 make negative 17. Absolute value of negative 17 is 17. 17 minus 15 is 2. All right, this time we've got 3 different variables. So we've got x equaling 5, y equaling negative 1, and z equaling negative 4. Now this one, since it's x minus y, notice that x is 5 and y is negative 1. So I'm actually going to do 5 minus a negative 1 in my absolute value. Plus. Now if you ever see minus a negative, that's where we want to change it into a superplus. So I'll work inside my parenthesis first, or inside my absolute value. 5 and 1 makes 6. If I take the absolute value of 6, I get 6. And then we just have to do PEMDAS from left to right, adding and subtracting from left to right. So 12 minus 6 is 6. 6 plus 4 is 10. Okay. So the absolute value of negative y. Now here's another little bit of a tricky thing. Negative y, well y is negative 1, so I'm going to do minus a negative 1 plus x, which is 5, minus 3 times z, which is negative 4. Again, I see a minus a negative, so I'm going to change it into a super plus. So instead of this being minus a negative 1, it's positive 1. 1 plus 5 makes 6. If I keep going from there, absolute value of 6 is 6. Negative 3 times negative 4 is positive 12. 12 and 6 make 18. So you've got to be really careful on those ones that you are following the problem exactly. If it's minus a negative, you have to change it into a chunky plus. All right, summary. Two different numbers may have the same absolute value because